he is exerting, you keep quiet. You exert 5 Newton force. Exert. Nula. Exert. Now, when you what are you just saying? You apply 5 Newton force. So he is going in that direction. Am I right? When he is applying force, he is going in that direction. Okay, now you leave. You apply 5 Newton force. He is applying 5 Newton force. So he is going in that direction. Am I right? Because this is the only force, based on that this is the acceleration. Now, you apply 5 Newton. You also apply 5 Newton. Just you try to apply. Now where the body is going? Where the body is going? Now, yes, listen my question. Listen, it's interesting. Whether forces are acting on the body or not.
Yes, sir.
Forces are there or not.
Yes, sir.
Answer to my question. Forces are there or not.
Yes, sir.
Yes, even though forces are there, why this body is not moving? That means, in this case, when these two forces are not there also, the body is in rest position. When they are applying equal forces in opposite direction also, the body is in rest position. The final result is same, but the situation is not same. In the first situation, no forces are acting. No force is there. That's why he is in rest position. When same forces but opposite in direction they are also acting, then also he is in rest position. So the final result is same, but the situation is not same. In the first situation there are no forces, but in the second situation there are the forces. There are the forces, but still the result is same. How? Because as you said, there are two forces, but they are of equal amount, opposite in direction. So what they are happening? They are applying on the same body. So these two forces are cancelling each other. So when they are cancelling, we say that the net force on the body is 0. So even though forces are there, they will cancel each other, and if the net force is 0, then the two forces are called as balanced forces. Then we call them as balanced forces, and this condition is called as balanced condition. This condition is called as balanced condition. Are you following?
Yes, sir.
Now, he is applying 7 Newton force. He is applying 5 Newton force. He is applying 7 Newton force. You have to apply like this. You have to apply 5 Newton force. Yes, try. Have you observed? Now, he is applying 7. He is applying 5. So, which is dominating? 7. How much? 2. So, now the body accelerates with how much of force? 2 Newton force, not 7 Newton. Among 7, 5 is cancelling here. So, remaining is how much? 2 Newton. That 2 Newton is responsible for this acceleration. So, when the two forces are there, which are of different in amount, opposite in direction, then among the greater force, you have to subtract the lower force. Therefore, you will get a net force. That net force is responsible for the acceleration. Then, such type of unequal forces acting on a body, we call them as unbalanced forces. We call them as unbalanced forces. So, this unbalanced forces is responsible for making the body to move. Are you getting my point?
Yes, sir.
Now, here, this force I will call it as F1. That force I will call it as F2. F1 minus F2 equals to net force, we will call. To this net force, I have to apply the MA formula. Are you following? Are you following? And this, the two forces of different amount, we call them as unbalanced forces. When they are of equal amount, on the same body, in opposite direction, we call them as balanced forces. Are you following? When the forces are balanced, the net force is equal to 0. When they are unbalanced, net force is not equal to 0. That's difference. We call it as net force. To that net force, if I apply the formula, then I can calculate the answer. Is it clear? Is it clear? Okay, thank you. Sit down.